Hello and welcome back to the channel. And in today's episode, I wanted to do something a little bit different than we normally do. From day to day, I'm working as a web developer, but a few months ago, I picked up a new hobby, which is learning and creating games. And I decided to share a little bit of that with you. You might figure it out from the last tutorial on this channel when I showed you how to create a snake game using React and TypeScript. And in the end of that tutorial, I mentioned that you should always pick the right tools for the job. And React is wonderful when it comes to creating web apps or mobile apps with React Native. Although, to be honest, for the mobile apps, I prefer Flutter. But it really lacks the correct set of tools and features to create a game. Creating a games was the reason I got into the programming in the first place. In my teen years, I've been handed a book called From Zero to Code Game Hero, which is a fake book about creating a tic-tac-toe game in C++. I have been avid player throughout all my life, and that's what I decided to try and look into game tutorials and how to create games once again. And in the very beginning, when I was researching that subject, I was forced to make a choice because I was sure I won't have time to learn about every single engine there is to create a game. I had to focus on one. And don't get me wrong, there are lots of wonderful engines for writing games, like Pygame or Phaser for creating games with JavaScript in web browsers. But what happened is actually I've heard about that game called Warhammer Hillsgate Demon Hunters. I love Warhammer and I love turn-based games. And I was watching the YouTube video about that game, and I saw that the engine they've decided to use for that game was Unity. And quickly I figured out that it is very popular and well established in the industry. So I decided to give it a go. So if you go to unity.com, you can find all the information you need about Unity right here. One important thing to note is that we will be writing code to make our games interactive, and the code will be written in C#, so that's an opportunity to learn a new language and new ecosystem. You've probably heard about Unreal Engine, which is second the most popular engine from what I believe. The Unreal Engine is using C++ to create a games. And since my whole company for which I'm currently working is using .NET Core, therefore I decided that I won't give it a try. I'd rather learn a little bit about C#, and I'm pretty pleased with it. So, but if you'd like to check Unreal Engine, there's a lot of materials for learning that. You can also go to learn.unity.com to find the whole whole new web page, whole new portal about learning how to become the Unity programmer, and I can't recommend it enough. It's really wonderful and guides you by the hand with the text and videos tutorials. It's really something else. The one problem for me, as I was trying to figure out how to use Unity, was that nowadays creating a game is really an artistic endeavor. If you look at the recent games that are published, they're not only fun, but they're also beautiful. And I'm in my nature, I'm not really an artistic person. I really cannot draw well, and I don't design even web pages that I create for the most of the time. Thankfully, Unity has a built-in graphic system for sprite renderers, so you can create simple graphics as we will right in the Unity. But also, if you find yourself needing more, you can go to itch.io and then click on game assets and maybe filter by free, and you'll find lots of wonderful assets here. For example, dungeon set, which is just, you can create any dungeon crawler with it. It looks really fine. Or alternatively, you could go to Unity Asset Store, which has now, I believe, integration with the Unity itself. And you can, for example, go to 2D, characters, then scroll down and check the free assets and enjoy a whole plethora of free game assets that you can import into Unity. So I'm going to be focusing on the developing and programming side of this. I'm not really the right person to teach you about graphics, but maybe a quick hint: if you'd like to learn a little bit about it, you should definitely check the pixel art, because it looks like it's the simplest of the arts, right? Something that you could probably pick up in a few weeks, and then maybe use that to create your own game. It looks really great, if you ask me. But if you'd like to learn about 3D, I cannot recommend enough the blender.org. Right, this is wonderful and free software for creating 3D graphics. When I was in the college, I was actually working a little bit as a 3D graphic designer, and I was using Blender to model the robots for our robotics students group. So yeah, definitely check out Blender. And with that done, we can get to Unity itself. What you should do is can probably get the individual personal license, but what you should do is you should go and download Unity Hub, which is the part of the Unity engine app, and it allows you to manage your Unity projects. I will be going with the beta solution, so that's Unity 2022. And once you download and install this, this is probably what you'll see, but your projects will be empty, I suppose. Here you already have the integration with the learning platform, which is just wonderful. You have access to the community, the installs, because you can have different version of the editor. And as you can see right here, I will be using the latest, the beta one, but you should be fine using the LTS version or 2021 too. So now I'm gonna create new project, and from the templates, I'm gonna choose the 2D, because what we'll do as our first tutorial here is I'm gonna recreate the game I created with React and TypeScript, just so that we can have some simple basis and understanding of the Unity editor and C# programming, and also so that we can compare the experience of creating these two games. So I'm gonna click create project, and it's gonna take a while to bootstrap this project. So I'll see you in a bit. Okay, so here we are with our newly created project in Unity, and I probably clicked 3D template instead of 2D, so I'm going to change it real quick. Yeah. So if you did that, you can disable the skybox, and now we are probably set up and ready to go. So let me start by discussing the basics of the UI that you see here, and be mindful that if you're using the previous versions of Unity, the UI might differ slightly. So let's start with the most important thing that you see here in the screen. And this is the scene panel. And basically what a scene is in Unity and how you can compare it to web development is, scene is something like a screen that you're presenting to the user or the player. Basically, the scene can be a menu or a part, like some kind of settings for a menu, or it might be a level or a part of a level. For example, if you take the game like Mario, when you're moving across the levels, probably each and single level is a separate scene. So I hope that makes sense. And here you have a few things that you can change in your scene. This is switching from 2D to 3D, and we're gonna use that a little bit. These are not important right now. These are tools that I will discuss as we bring some game objects to the scene that allow you to manipulate objects on your scene. And this is a hand tool, the move tool, rotate, scale, rectangle, and transform tool. And you can move across the scene by using the middle mouse button or right mouse button. Just click and drag. And this is perfect for 2D, as we'll try to move across our scene and see different game objects. Now, the second panel that is really important, and let me switch to that, is a game panel. And this will trigger and represent your game inside of the Unity engine. So here we will be testing our game and see how it works and where it plays correctly. Be minded that this is not the final product, not a built game. This is more like when you're using React and you have web development server, this is more like it. So the performance of the finished and built game might be actually different, and we're hoping better than the one running inside of Unity engine. The next important panel is hierarchy that we see right here. And basically, this is like a component tree for your React app, right? This allows you to bring the game objects to the Unity engine and match them up in a parent-child relationships. So, for example, if you have a player and your player has a gun, then probably the gun game object is a child of the parent player game object. And this is almost the same like with the React. You should compose smaller and simpler game objects into bigger, more smart, more complex game objects. Currently, what we have in our hierarchy is main camera, which is represented in our game scene as this rectangular area, and this is basically what you will see in your game, right? So the camera can try and follow our player, or maybe you'd like to create a co-op game and you have to put two cameras in the scene to create a split screen. And there's also directional light, which sheds the light into our scene and allow our objects to be highlighted. But discussing the lights is not a purpose of the tutorial, as it will take too long. Okay, if we click on one of our game objects, what you will see on your right is inspector panel. And this is kind of like the inspector panel in the web development tools, for example, Chrome DevTools, because it will show all the properties of your game object. And as you can see, each game object is created by a few properties called components. And they are similar, in my mind at least, in my mental model, to the React components. Meaning each and every component should do one job and do it good, and then you can reuse those. If we click to directional light, you can see that it is built by transform and light component with different set of properties. Also, camera is built by transform and camera component. And this transform component is very important, and you can use it to manipulate the position and rotation or a scale of a given game object. So whenever we decide to move our player, we probably should change its position, right? And it's used in almost every single game object, okay? So the things that you have in a hierarchy are game objects, and they're built with different components. Then there are two last panels here at the bottom, the project and the console. And the project, as you may imagine, is basically like your file explorer. So every single piece of, every single script, every graphic, every asset, scene, or sound in your game will be in the assets folder here and can be used to create or manipulate game objects. So here we will create folders, add files, so forth and so on, just like File Explorer in Visual Studio Code. And then there's the console, which is good old debugging console. Every single error about your code, whenever you make one, will pop up in here. Also, every single issue with every single thing that you will log out, because we can do console logs in Unity, will also be shown here. Okay, so with those basic panels in the UI described, let's start working on our Snake game. So whenever I click on given game object, I can press F, like feature, to focus into that object. And I can see my camera here. And in the camera component, I'm going to change the background to black. So first thing that we've got to do is to add the player to our game. And I'm going to add that game object by clicking create objects, and there should be 2D right here. Okay, so I wanted to add a 2D object, but it's not in the context menu. And this is because I probably configured the project as a 3D instead of 2D, but we can fix that really easy. We can add a package that is responsible for adding 2D sprites into our game. And this is similar to NPM package registry. So you go to the window and you go to package manager. And here you can find probably all the packages that are available for us. You have to switch from packages in project to Unity registry, and then you can search for 2D sprite, and there it is. And you click install. And now with that added, we have 2D objects in our context menu. If you clicked on 2D game, then you're good to go and you don't have to do that. So let's go to sprites and square. And we've added square sprite, and we can name it snake, which should be a proper name for that. And what we have to do is to change the color to green, and then we will reset the transform to position it in the middle of our camera. Okay, and if we take a look at the 3D, we can see that it's there. One thing though, as I'm looking in our camera, probably we'd like to change the size of it to make it a little bit bigger. So this is the main camera. There's the field of view. There are clipping planes. And as I manipulate the Z-axis, right, you can see that our camera view is getting bigger. So let me talk quickly about this. If you switch to 3D view, you can see that when I have the move tool selected, there are 3 axes that I can manipulate and change the position. That's the Z-axis, the Y-axis, the Y-axis, just click and drag, and the X-axis, because we're in a 3D world. So even if you're creating a 2D world, you can still manipulate the Z-axis. For example, when you like to have a background and then a player on that background. This is like Z-index in web development. So let's see how our game looks like. Maybe we can bring it farther away even more to have more space and more room to play with. Okay, I believe that going with -40 should be good, and then put that on 0. Okay, that looks good. Our snake. our wonderful snake. Let's switch back to 2D. It has a standard scale of 1, so this is good. It's got the sprite renderer, this is fine, and this is the component responsible for rendering the 2D sprite. So let's create another one, and I'm going to call it food, and I'm going to turn it to red. The position will be irrelevant for now. So clicking on our camera and checking our, let's try and run our game and see how it looks. Okay, this is looking fine. Probably what we could add are some borders to the game grid, right? So I can add another to the object and choose the square, and I will call it bottom wall. And I'm gonna turn it grayish, something like that will be fine. Let's focus on that. Let's reset the transform. Okay, and now we have to turn it into a wall. So what I'm going to do is I'm going to bring it down a little bit, and I'm going to scale it in y-axis. Sorry, the x-axis. Let's see on our camera. Actually, let me just bring it here so that we can see what we're working with. Make a little bit of room for that. Okay. Now I can continue scaling and find the proper values. Something like that, and maybe bring it down to here. And we're working on a grid with the unit of 1, so probably what you'd like here is working with one nice rounded values. So 70 here and minus 17 and half. That should be good. So this is our bottom border of our gameplay area. Let's create another one and bring it to the top. So I'm gonna duplicate that, and I'm gonna change its position from minus to plus. That's fine. And then we need the left and right. So this is going to be renamed to upper wall. And I'm going to duplicate that. I'm going to scale it back to 35. Bring it down, rotate it 90 degrees, and that's going to be on the Z axis. Okay, and 0, and push it back. So probably something like 35 is gonna be okay. And this is right wall, duplicate, change it to left wall, and then bring it to minus 35. And with that, okay, and our game, that's one probability. We're still in the play, we're still playing the game because this was highlighted in blue, and every single change you do whenever the game is playing is simply destroyed after you stop playing it. So basically you have to do it once again. Sorry for that. I will try to speed it up on the recording. Yeah, so there's a lesson in that. For example, if I click play, and I go to a scene and I change the color of my snake to something pink, right? If I stop playing, the changes are removed. Something very important to remember. Okay, but with that done, I believe we have everything we need to start working on the code for our game. So writing the code in Unity is being done by the scripts. So I'm going to create new folder called scripts. And quick note about folder structure. You know that in React and TypeScript, I tend to group stuff by the context rather by its type. But since this is going to be a very simple game, I believe that grouping by type will be fine. What I mean by that is if I were to build more complex game, and I would have stuff like sounds for a player, the scripts for a player, the graphics for a player, I would probably create one folder named player and put everything related there because it's closer and it shares the same context instead of creating stuff like folder graphics and folder scripts and so on and so forth. But since this is going to be very simple, let me just group it here. I'm going to click right here and I'm going to choose C# script and name it snake. And what we'll do is we'll try to make our snake move a little bit. So with that, I can double click and it will open. And what you will see happening is that I have this open in Visual Studio Code. And there's a reason for it. And the reason is you definitely can make it work with Visual Studio Code. If you search for Visual Studio Code Unity, you'll get the whole document telling you how to set it up with Visual Studio Code. But by default, for C#, I believe that Visual Studio, especially the version I'm rocking, which is 2022, the latest, is really good. The autocomplete is really nice. The experience is really smooth. So I decided to stick with that. And I can click Solution Explorer here and I will see all the scripts I have here. So this is the bare bones script generated for us by Unity. And as you can see here, it's already filled with some stuff. One thing to note when we're building web projects and React projects, we rely on functions more so than on classes. In Unity, every script is a class that extends mono behavior. And this is the mono behavior is a class that is underlying and has those starts, update, basically every single thing that connects to Unity editor is in mono behavior. So we have a start and update function, and start is like your component did map. So it's the function that will run once at the start. And then there's update, which is like your render, which is triggered many times during 1 second, and basically is responsible for rendering and updating given game object. Okay, so we can check that by simply adding debug log here, saying I will trigger once. And then here we can add, this is like console log. I will trigger many times. So we have a piece of code the question is how to run it. And basically, if you'd like to run a script in C#, it has to be attached to some game object. And Snake game object seems like a good place to attach the Snake script. So let's do just that. And you can do it in two ways. You can drag and drop it onto game object you'd like to attach it to, or I could click the game object, go to add component, and then search for a script I would like to add and press enter. And this is now attached. Of course, it's not running because our game is not running, but if I click play, in console you will see I will trigger once, and then many updates that are happening for the update function. Okay, so let's try and figure out how can we move our snake. So first things first, I'm gonna need and decide on direction in which our snake should be moving. So I'm gonna create private vector2 direction, and I'm gonna attach to vector0. And what is kind of cool about creating games is that you have to know your way around basic math, which is not really necessary for web development. So what is vector2? Vector2 is a tuple that holds two values, well, because it's a tuple, that represent the x and y values, right? So if you remember your math, this is x and y. And for example, if I find a point that is 2 for x and 1 for y, I can draw a vector to it, right? So let me maybe change the color of it. So this is a vector. And vector 0 is, of course, of value 0, 0. And this is describing the direction in which we'd like to move. And at the very start, we don't want our snake to move at all. That should be done only whenever someone presses a key. So let's handle that. In a update, I can write input x, and this is a float that will describe the change in the direction based on what key was pressed by the user. So if he presses A or D, or left arrow or right arrow on the keyboard, this will start getting the positive or negative values. And I can go to input, get axis, and say that I would like to get the horizontal axis. Read that by axis to get that value. And already a few things here. The functions, the methods in C# are written in uppercase. That's one. And also it's strongly typed and there's no number. There's a float, there's int. So there are different types for your numeric values. And the same goes for the input on Y. So input, get axis, vertical. Okay, and we can log those and see what is going on there. So input X and input Y. Okay, let's run it. And here you can see 0 many times, but as I am pressing the keys and it's not changing, probably because I didn't save something. Input X, input Y, let's try that again. Let's clear the console. Still not. Okay. It is working, as you may see. Just need to yeah, that's true. Of course, I just have to first click on the game to get a focus. And then, as you can see, as I'm pressing the WSAD, the values for input X and input Y are changing. Okay, so that should allow us to decide upon the direction in which our snake should be moving. So let's check for input X first. If it's greater than 0, that means we should be moving right. And I could do it by creating new vector and specifying these values, like moving right, so move 1 unit to the right with 1 and 0. But actually, these are predefined as vector right, same as vector 0 here. Okay, so if the input X is less than 0, should set the direction to vector left. And as you can see, you have to end every line in C# with the semicolon. Then do else if input Y is greater than 0, else if input Y is less than 0. Okay, so we get the direction, we get the vector. If it's greater than 0, we should go up. If direction, then vector to down. Okay, and that decides on the direction, which is fine. Now, we should decide now upon moving, right? Because we like to animate our snake and we like to give him some speed. So what I'm going to do is I'm going to create a public variable here, load speed, and I'm going to set it to something like that. And this is public for a reason. You could do public, or you could do serialized field, which I'm going to do in a second. And then if you click on a given game object with a script and find that script section, you can see that this has been exposed to Unity editor, which is wonderful because now you can change it from an editor and manipulate it with ease. I believe that the alternative, if you'd not like to make it public, which makes it accessible to accessible from that class in different classes, you could do private and then add a serialized field decorator here. And if I'm correct, yeah, this is still available in Unity editor, but that variable is not exposed to different parts of code. Okay, so let's go with that. We have our speed, and now what we have to do is, just like we did in the web version, we have to set interval that will trigger the movement of our snake. And that can be done rather easily because there's a function called invoke repeating. And this is like set terminal. So what you're passing here is the method that we would like to trigger. For us, it's going to be update position. the delay before the first trigger, which is going to be 0, and then how often it should be repeated. And I'm going to do 1 divided by speed, right? Which basically means the greater the speed, the more often it's going to be repeated. If the speed is 2, that's going to be a half, so it is called 2 times a second. But if the speed is 4, then it's going to be called 4 times a second, right? So let's do the speed. And now it's time to create that function. So let's do private void update position. Okay, great. So what we have to read first is current position of our head. This is vector free head position. And you might wonder, why are we using vector free if we're building to the game? Well, we're gonna read from a transform. So basically what we're gonna do is this transform position. And what it's going to do, that line of code, right, is gonna reach into the game object's transform component and read its position value. And since we have three values here, x, y, and z, therefore we need a vector free to store x, y, and z, while the vector 2 could hold only x and y. Okay, one cool thing about C#, you don't need really to call to this, which is like self, to read from the properties that are in that class. So we can omit that. And we can create then new position to which our snake head should be moved. So that's going to be new vector free, and we're gonna take head position x and add the direction x, so move it 1 unit, and then we're gonna take head position y and add the direction y, and for z that's gonna be 0. And I'm putting f here to use floats instead of integers. Okay, so that's cool. And then I can just reattach and change our transform position to new position. Okay, so we're reading current position, then changing it based on the direction. So based on which keyboard key was clicked, was tapped by our player, and then changing the transform position. And this should be enough to make our snake work. And you can see that it's working pretty nicely. Okay, so what we're doing here is we're moving, but we can go, unfortunately, out of the boundaries of our game. Okay, so let's try figuring out how to limit our movement of our snake to the grid area. So basically what we had to do in the web version is that we had to check manually where we're staying in the predefined x and y coordinates. Thankfully, in Unity, it is way simple, way more simple, because the Unity has components to detect the collision. And what we can do is we can add a collision detection component to every single of our walls and to our snake. So go to a snake and click add components and choose box collider, and you will see two, box collider and box collider 2D. And since we're working with 2D game, I'm gonna do box collider 2D. And one thing to note, as you will see immediately, it has the size the same as our snake, so it's matching it perfectly. But that's actually gonna be a little bit of a problem, and I'm gonna explain why. Later in our game, our snake is going to grow and have more segments. And the game over state will be whenever the snake crashes into itself. So if we have another segment and this box collider is close enough to touch that box collider, then it's like automatically crashing into itself, even though it shouldn't. So to fix that issue, what we can do is to lower the size of our box collider slightly. So make it 0.9 and 0.9. And if I'm going to click here to edit the collider, you can see it's smaller than what we were rendering on the screen, and this is fine. To check for collision, we also need to add the box colliders to our walls. So I'm going to do the same. And actually, in that case, I'm going to make them a little bit bigger. So I can just click on that dot here and drag it up slightly, right? Why is that? Well, because we're moving the snake in the units of 1, and we have to stop him right on the edge and not like inside of our collider. So extending that a little bit slightly will make him collide sooner, which is what we actually need right here. So let's make it, we don't need an offset, no, but let's make it 1.1, and that should be, and maybe offset of 0.1. Not really. The offset of, yeah, that's correct. So offset of 0.05 and size of 1.1. And let's do the same here. So the size should be in x 1.1. In the x, oh, this is rotated. Okay, so no, since this is rotated, let's do 1.1 here. Okay, and let's check our box collider. Oh, there's a size of 1. Okay, so wrong, that should be actually be negative because we're moving inside our grid area. Same here. At box collider, size 1.1, and in the Y, of course, and then positive value, I think, and remove that. I don't know why is this happening. Yeah, okay, negative then. Okay, and the last one, the same. So this is rotated, so still 1.1, and that's good, and minus 0.05. Okay, it's plus. Okay, and we're all set with our box colliders. So let's check if we actually can detect hitting into a wall. So there are two types of collisions in Unity. Basically, if you have one box that has a box collider or any other game object, and the second one, and let's say that the yellow is moving with some kind of velocity, basic physics. What will happen is, according to the second law of Newton, is whenever these two hit, they both will affect each other, pushing themselves out. So it's like whenever you crash into a wall, you'll be bounced back. But because of the physics nature of the wall, well, you're not gonna push the ball back, right? The wall back. But if you're gonna hit a very sturdy and heavy ball, then you can be pushed back and the ball can start rolling in front. And this is by default calculated by the physics game engine in Unity. And one note, maybe a little nerdy one, when we're talking about the physics of game engine, what we basically mean is not stuff like, I don't know, electricity or thermodynamics. Basically, we're talking about mechanics, dynamics, rigid bodies, and kinematics, right? This is the physics that you're interested in your game. So basically, what we don't want in our game is whenever the sneaks hits the wall to bounce back or move the wall. We need to be notified and we'd like to do something about it. So to change that behavior, we go to the box collider and we check is trigger checkbox. And the same here. And then you will be informed that the collision happened, but the physics engine will not try to do the physics calculations. And then we can use that and be informed about that by using on trigger enter 2D callback. And for now, let's add debug log here, and let's say I hit the wall. And let's see whether we'll actually get that information. So I'm running the game, and I'm moving. And as you can see, right now, there's no information about collision. And that's because we're missing one important component. So let's go to our snake, and we have to find rigid body 2D. And this is the component that allows for a given game object to have physics-induced behavior. If you take a look here, there's a gravity scale. So whether our object is going to be affected by gravity, angular drag, which is how far or how much can given object rotate or roll before being stopped. The linear drag, this goes the same, but this is for moving across the plane, and the mass. And if I play our game right now, what you will see is that our wonderful snake is affected by the gravity and it starts falling down. So definitely not something that you'd like. What we need actually is to change our body type to kinematic, and this is where we are interested in the movement of our game object, but not really in the mass, gravity, and so on. So let's try now. I'm running this, and as soon as I add the rigid body, you can see that we're getting the information about wall being hit. So that's really wonderful. So rigid body 2D was what we were missing. Knowing that, we can try and figure out what to do whenever we hit a wall. But jumping a little bit into the future, we will, in our game, the wall is not the only thing that we can hit. We can also hit the food and ourselves. And we have to find a way to distinguish between these. Okay, so we can do that by adding an ID, just like you do for HTML elements, to get the specific one, using, for example, document getElement by ID. And we can do that by using tags. So I want a wall tag, a food tag, and a player tag. And if you click on any of the game objects, here at the top, you will find a tag. And that's what we're missing right now from our game objects. And I would like to mark it as a wall, and we can find few predefined tags here. But I can click to add tag, and we're taken to tags and layers window automatically. And here's a list of tags that are available for you in your game. And since this is empty, I can create one. I'm going to create a wall tag, and I'm going to create a food tag because we have the player in the default list. And now I can start marking stuff with the tag. So this is the wall. This is the player. This is the food and the player. Sorry, this is the food. And then each and single wall can be marked as a wall, 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 and wall. Okay, so given that, I can check for something like collision tag. And if I play that now, I have my tag displayed in the console and it's a wall. Okay, so using simple if statement, I can decide what to do. If collision tag is equal to wall, I will trigger on wall hit function that we have now to create. Okay, so basically this is gonna be a little bit complex, but one version of the game is that, as you know, whenever you hit a wall, you just die. That's not so cool. What I'd like to do is make our snake a little bit smarter and make him move in a different direction based on the current snake position and the wall that was hit. So for example, if we hit a wall right here, I would like my snake to automatically start going left into the middle. And if I hit the wall here, I would like for him to again move into the middle, the same here and here. Okay, so that's the principle of the movement whenever you hit a wall. And this can be achieved very easily, but we have to use some tricks. Okay, because we know that we've hit a wall, but we don't know in which direction things should start automatically moving. So let's start by creating a function, private void on wall hit. Okay, and I'm gonna introduce another variable here, which is going to be vector2, and I'm gonna call it direction candidate, and that's gonna start our vector 0. because we will have to decide the final direction based on few different information, and direction candidate gonna help us with that. Okay, so to make this work, I'm gonna check for a current direction, whether it's up or whether it's down. Okay, so this is first, and then of course we have to check for the second scenario where we have vector left, or the direction is vector right. Okay, and now we have to check the place where we hit the wall. So where we're on the left side or the right side, or at the upper or bottom side. So for up and down, we're gonna check the transform position x and check whether it's greater or equal to 0. And then there's the else statement. So let me just show you. We're moving up or down, and we're checking, and this is the middle line for the x, and we're checking right now whether we fit that part of the wall or that one, so whether the x is bigger or smaller than 0. So if we did that, then we're gonna set the direction to vector left, and we're gonna check the direction candidate to to the same value. I know that adding that direction candidate might be a little bit confusing, but please bear with me. The same is gonna go for the opposite situation, which is gonna be right and right. Okay, then here we're gonna check for the y and set this to down or up. Okay, and now we're able to change this to change our update position. Sorry, our update function. So basically, that should already work a little bit, but you'll see the problem soon. Okay, this is almost working. Or is it? Oh yeah, that's the problem. You see, we can move across the border, but it's also going to work. But we've seen the scenario where it wasn't. Okay, so the problem is whenever I am sliding across the wall, for example, the left wall, I am still able to change direction to the left and go across, right? Or whenever I'm sliding on the right wall or the bottom, I can press bottom and escape from, from our grid area. So we have to introduce the mechanism to prevent that. And why is this possible? Well, you might think that with box collider and rigid body, it should work like a barricade. You cannot move through it. But actually, what we did is we mark our box colliders as triggers. So whenever we're just informed about the collision whenever someone is colliding with the wall, but we're not letting the physics calculate that, hey, this is a blockade and it has a mass, so you cannot move through it. So what we can do is create another, we can create another game object, and I'm going to create an empty. I'm going to call this grid area or game area. I'm going to reset the transform to 0, 0, 0 to make it sit in the center. And I'm going to add a box collider 2D to it. And we're going to use this in a slightly different manner. So I'm going to scale it to match the grid area. So as we start to grow, that should be probably 70, right? We have to match this perfectly, basically. Then this is like, I don't know, 50, 45. You can scale it down to. Let me take a closer look at it. So it looks like 59. Okay, and then for that, it's going to be 69. Nice. And position should be, oh, that should be 0. So, oh, actually it's 70. Or is it? It's 70, no, it's 69. We're offset, we have a little bit of offset here. Is it -1? Yeah, -1. Okay. And we have an empty box collider. Empty basically means it's not gonna render into a screen, but it's often used to mark stuff, and it's really powerful. And now moving back to our code, I'm gonna make, we have to make use of that grid area inside of our snake script, meaning we have to have a reference to a different game object than the one we attach the script to. So I'm gonna make a reference here by creating a public box collider 2D, because that's the type of game component, and set this as game area. Okay, and I can make public, or I can make serialized field private. It's really up to you. If you're not going to use that game component in different script than that class, you can probably make it private and serialized field. But just to show you that these both work, I'm going to mark it as public. So now going to my snake, I'm going to find the script. And here you can see that box collider exposed, and I can just drag and drop it here, and that's going to take the box collider 2D from game area game object. So that should be now filled and ready to go. Okay, so we're going to our update, and we have to change that direction to direction candidate. And why is that? Because as we have seen, there is a situation where we cannot change the transform position of our snake based on the direction. When we're sliding here, going down, and we set the direction to left, we shouldn't move across our boundaries. Rather, we should check whether we are able to move outside of that boundaries. And if not, we should just keep going with the previous direction. Therefore, we're using direction candidate as a candidate to check whether we can move in that direction and not to immediately move in that direction because we can go across the wall. So yeah, we're changing that to direction candidate, and then we have to do one other calculation, which is boolean show, so true or false, should update direction. And given the fact that we have that game area, we can access its bounds and check whether this contains the new change position for our snake. So we can check whether transform position x plus direction candidate x and transform position y, direction y, and probably the z is, of course, 0, 0f. So we can check whether the new position to which we would move with direction candidate is staying within the game area bounds. And if not, we're going to just return from the function. And if it is, actually, we're going to update the direction to direction candidate. Okay, so this is the scenario when we're providing sliding across the wall and then moving outside of boundaries of our game. So let's try that now. Okay, and I'm at the left wall, clicking left, and I cannot move. And I can move up, unfortunately, probably because we're missing something. So this is left, right, upper, bottom, right, left, up, down, left, right, oh, probably, that's probably because we're missing if statements here. Transform position X. And then check for transform position Y. Let's reload. Let's try that now. Okay, so we're sliding, we can go left, and we still can go up. Same probably for the bottom. Yeah, so it's working for the right, but not the top. Oh, I know. We're missing some stuff for changing the direction candidate. So we have to check whether the direction is not equal to vector 2. We have to extend our if statement here. We have to check for the left and check whether the direction candidate is not equal to vector 2 left. Here we're going to do the same. but for the right. And here we're gonna have to do the same for the direction down. Or basically we don't have to check that. The direction itself should be enough. Vector 2 down and vector 2 up. The direction, yeah. Okay, let's try that again. No errors, no errors. Okay, I still can go up. Okay, so yeah, probably we need to check for the direction candidate. Direction candidate vector 2 left. Direction candidate vector 2 down. Vector 2 up. Let's try that again. As you may have seen, I'm not so perfect when it comes to Unity, and we cannot move at all, so that's bad. Okay, so of course we have a typo. This is working for the left and right because we're taking into an account direction candidate, and here's a typo. It should be direction candidate instead of direction. So yeah, of course, if you think your code is not working, check for typos. Okay, so now it looks like it is working. So with that, we can start working on our second script, the food script. So let's create a new one. It's going to be C# script and name it food. Basically, we have to detect the collision between the player and the food. And also we have to randomize the position of our food whenever it is eaten or whenever starting the game. And also, as you can see right now, it is sitting in the decimal values, and I would like for it to be on a grid, meaning to have those values always be full round numbers, right? So let's fire up the food script. Okay, and here we don't need updates, so let's get rid of that. And what we need is to randomize the position of our food. So I'm going to create a private void randomize food position function. And also we have to be sure that our food is within the bounds of our game area. So I'm going to create public box collider 2D here with grid area. And let's start by attaching that game area to our script. So we have to attach the script to the food and then game area to fill the grid area. Well, change it to game area to fill that property. Okay, and it seems we changed the name and we have to reattach it, but that's not a problem. So let's read the bounds of our game area. So these are the bounds and this game area bounds, and let's calculate the position for x. That's going to be math, and math f is the module for common math functions, and we need a round to get the round value, and we're gonna get the random range, and we can specify the starting and the ending value for a range. So these, of course, gonna be starting position of the bounds and ending position on the bounds on the x-axis, and then there is the starting position on and ending position on the y-axis. So these are the bounds within which our food can spawn. So that's gonna be bounds minimum x and bounds maximum x, and then we're gonna have the same for the y. So bounds minimum y and bounds maximum y. And then we just transform the position to new vector 3, x, y, and 0. And we have to call it on the start. So now, if I play my game and restart it again, we can see that the food position should be different each and single time. Nice. So we have that covered. Okay, we also have to check for collision here. So let's add box collider 2D and mark it as isTrigger, because we have to change that position whenever the player hits the food. So let's search for on trigger enter 2D and check for, just to be sure, collision tag, check for it to be the player. We call randomize food position. And this is fast, but I'm not good at this game, but let's try and eat our food. And okay, yeah, so as you can see, the food position is being changed every time I eat it, and I have to slow my snake down because I don't have the reflexes to play that game. Okay. So with that done, we're almost through the woods. We have to basically write the code that will allow our player to grow. So not in our food, but in our snake, let's check for a different tag. If collision tag collision emit is equal to food. I'm going to create a function called grow, because basically that's what's going to happen. So let's go here and do private void grow. Yeah, and how to figure that one out? We'll have to add segments that behaves the same to our snake, because basically it is extending. So, and there can be many segments and each should behave the same way. So if you find yourself in a situation where you know you will be creating the reusable components in Unity, you actually have to create a prefab. And it should behave just like the head of the snake, except it shouldn't have the script attached because this script is attached to that head. So what I'm going to do is I'm going to clone that and call that snake segment. So this is new game object. I'm going to remove the script component from it. And if you'd like to create that prefab, that reusable game object, you can create new folder, call it prefabs. And the simplest way to create that, as you can see, it is in our scene, is to take that and drag it into a folder in your project panel. And as you can see here, that created the snake segment .prefab file. And this is a prefabricate that we can reuse. We will add and attach those segments using the code, so you can get rid of the prefab from the hierarchy by deleting it. And first thing that we have to figure out to add this is the position on which we should add given segment. So let's imagine a situation. This is our food. This is our snake's head, and it is moving down to eat it, right? So in the next frame, it's going to be right here. And that segment, the new segment, let me color it in yellow, should then pop in the previous head position. So we have to decide what should be the starting position of the segment that we'd like to instantiate into our game. And this is based on the direction. I know if that we're moving down, then I should take the head position and add -1 or subtract 1 on the y-axis, right? If I were starting from this position and moving up, then I should probably add 1 to to y-axis to place the new segment in the current position. The same goes for x-axis, where this should be +1 on the x, that should be -1 on the x, because based on the previous movement of our snake, we have to decide where to put the next segment. Okay, that was a lot of talking, so let's try figuring out the place for the next segment. So I'm going to create vector3, and I'm going to call it new segment position. Let's set it to transform position. I'm back after the break, and it's first time. I had to split this recording into two. This is as one because I will compile it into one in a video editing software. It's first time ever I'm having my glasses on for the computer and for reading, and everything is so crystal clear, but strange. Anyways, we are in our grow function, And we have to decide on the position of our new segment that we'll be adding. So we have to basically check for the current direction. We're checking for the right. We're checking for the left. Vector to left. So basically we're going through all the possible directions. Direction, vector, vector to down, vector to up. Okay, and based on that, we will assign new value to our new segment position. And this should be, we can do the incrementation. So plus equals, and that's going to be vector. If we're on the left, then the position, if we're on the right, the position should be on the left. Then vector right. Position. Vector up. And down. Okay. So we have the new position decided. The one thing now is to actually add the new segment to our game and to our game objects hierarchy. And this is actually interesting because Unity has this cool method called instantiate, right? And this clone, that's not really, well, that's not really what is going on, but basically what you do here is you can pass any game object, and for us it should be segment prefab. Do we have this? No, I don't think so. So let's add this. It's going to be private transform segment prefab, and I'm gonna use the serialize field decorator here. So going back to our Unity, we have why is it not showing? There's an error. Let's comment that out for now. That's commented. It's gonna reload. Okay, and now if we go to our snake, we can see the segment prefab, and I'm just gonna take the snake segment and put it in here, and we can get back to it and work with that. So you're passing a game object that you'd like to add to your game and add to your game objects hierarchy, and then you have to pass its position, starting position, the position in which it should be spawned, and then you have to specify the rotation. And this is actually interesting because when working in Unity, we have two types of units that describe the rotation. The Euler angles that you know from the math from the school, and there's also that interesting concept of, just find this quaternion. And they're used to represent the rotations. From what I know, they're used because it's easy to perform calculations on them, it's easy to transform quaternions to Euler angles. But if you'd like to figure out more about quaternions, I definitely encourage you to, but they're not really something I would like to explain on that current level because they can get quite complicated. But basically, we're starting with no rotation for our segment, so I can just pass quaternion identity, which means basically no rotation, and then I'm gonna, and that's gonna create our segment. But now what we actually have to do is to sort those segments so that we can animate those later. So since our snake is actually an array of segments, we will create one. And in C#, if you'd like to create an array, you basically need a list. They're the same. This is a list of transform, and I'm gonna call this segments. One thing that we have to do at the very start is add our head to the segment. So I'm gonna say segments. That's gonna be new list of transforms, and segments add this transform, and you don't need this keyword. Okay, so now I can add our segments, and I'm gonna not use the add method, but insert to specify the index on which you should add another segment. And basically, if we take a look at our snake, however it is created, that's gonna be the head. It's always gonna be at 0. Then we have, of course, 1 and 2. But whenever we eat some kind of food, so this is our food, I would like to insert the new segment created by eating the food just behind the head, so at the segment, at the index number 1. Okay, so I'm gonna insert at 1 and segment. Okay, so let's see if that's working at least a little bit. Okay, so let me extend that, and I'm moving, and this is really fast. And I'm and we're spawning a segment. The problem now is it's not following along at all. It's just staying at the place it was instantiated. Okay, so we have to make our segments move with the head. And the simplest approach for our snake would be to iterate over the segments, and this is the head, and move each and single one unit. So you're taking the head, moving one unit, then you iterate to the second one and the third one, and you're moving them. But actually there's more efficient way, and I think it's kind of nice to implement. So if you take a look at our snake, first thing that we're doing, we're moving our head one step further, right? And basically what that creates is a gap between our head and the rest of the body. And we can plug that gap by taking the last segment for our snake and moving it forward. And then the previous element in the body now becomes the last element. Okay, so we don't have to iterate all segments and move them across. We just need to move the head and last element, and it will still be the same, like our snake is moving along. So let's try figuring that one out. Basically, we should go to update position function, and it is here, and check for the segment's head count. If segment count is equal to 1, basically if it's equal or less than 1, we can return. And if you know my programming style, I always, if it's possible, prefer the early returns. That's more readable for me because I'm reading that function, and if I hit that specific case scenario, oh, this is the end, I don't have to bother with anything else, and we avoid the if pyramid. So if our snake is longer than 1, has more than one segment, we get the last segment by reaching into segments and segments count -1, and the last segment position, we set it to be the head position. We already moved our head ahead funny, in this line, so this is like previous head position. Okay, and that's, as I was drawing, this is pushing the last segment into the place where head previously was positioned. And then we can just change the array by inserting the last segment, to remember about that, into the first index and removing the last segment. So remove at segments count -1. So we're changing the position of the last segment and then also changing its position inside of our list and removing the last segment to avoid duplicates. And with that done, let me just, we have our snake following along nicely, so that's really great. And even if we hit the wall, it's still running. Okay, one thing we can change just to make it a little bit nicer, we can change the snake's head to be a little bit bigger than the rest of our elements, so maybe make it 1.1. Okay, and yeah, our prefab is still at 1.1. So let me just make it visually bigger. Let's change the speed maybe to something like, I don't know, 20. And let's see if it's running. Yeah, now it's slower. And you can see now we can distinguish between the head and the rest of the body, which is really nice if you ever wonder where's the head. Okay, yeah, with this lower speed I can still play. Okay, so basically there's a little bit that we still have to do. One thing is the scenario when we're colliding with ourselves. So if collision tag is equal to player, basically we have to handle some kind of game over. So let's just do game over. We can collapse that and write the game over function. how do you, okay. So private void game over. Two things we have to do here. We have to cancel our interval by calling cancel invoke, update position, and basically that will stop the game. But to make it a little bit more user-friendly, I would like to add some kind of UI, very simple UI, to our game. And we can do that by going to UI, and whenever we pick one of these, we can start adding stuff. Like these are buttons, images, and so forth. So maybe let's start. Okay. Let's import this. Okay. So what we're getting is a canvas that overlays on top of our game and some UI elements that we can add. So let's take a look at that. We had the new text and it is positioned right here. Okay. So maybe we'll show some points for our player. And since this is a very simple and vintage-like game, let's go to fonts. Let's go to Google Fonts and search for some font that will look like pixels. Pixels. Google font pixelated. Okay. No, not pixelated. Google Fonts, Pixel Fonts. Okay, and we have one candidate, and it's looking nice enough for me. So let's get to our downloads. And if you just go to Unity, you can create another folder here, call it fonts. Okay, and then you can basically drag the downloaded font into the project. So what I'm doing is just extracting that and grabbing the TTF file and putting it right here. So now I can go to my wonderful font, and probably I'm just going to grab that font and can I drop it here? Not really. Okay, so basically we don't want that text TMP. Either have UI and where is it? UI legacy text. Okay, that's gonna be good enough. Probably in the earlier versions of Unity, you don't have that TMP and you can just grab text. Then we can probably get rid of that whole folder. This is just because we're working with the latest version of Unity. You can get that text, drag that font right here. And now let's start thinking about positioning that. So here in the transform, rectangle transform for that for that UI element, you can choose top and middle, right? And that's gonna, if you press Alt, you can see that you can snap it to the tab. I'm gonna increase the font size, change the color, yep, to white, and say something like your score is 0, and it's not visible because we have to change the width. Okay, maybe bump the font size just ever so slightly. That would require us to change the height too. Okay, and maybe change the position Y a little bit and more width. Okay, set the text to be centered, and that is enough for us to display that score for the user. So what I'm going to do is I'm going to create a new script to handle the UI stuff, and this is going to be C# script, and I'm going to call this UI. Yep, and I'm going to actually attach it to the canvas. Yeah, that makes sense. Get rid of all of that, but I'm going to create the reference to the text I just added. So private text, and to use the UI classes for the Unity engine, you probably have to add Unity engine UI. Okay, and now I can create reference to text score text. Okay, I'm going to serialize that field, and I'm going to create a function that's going to be public, and I'm going to call this increase score. Yeah, and that function is going to take an argument. It's going to take the integer points, and then I can take the score text and set the text to something like we can, you know that in JavaScript you have template string root literals. The same string interpolation is available in C# by $. So I can say your score is, let's say, points. Okay, so that way we can increase the score. If we go to the snake, we probably need a reference to the UI. So again, let's do private UI, and that's going to be also a serialized field, but again, you can make it public. Now, in a snake, we see that the UI is empty. You can drag the canvas here, and it's going to pass the canvas class. So then, whenever we grow, in the end, we can just say UI increase score, and the points, that's going to be segments count, And just for fun, let's do times 10. Okay, and see whether this works. Okay, we're starting with nothing. And okay, object reference is not set to instance of an object, so we have an error here. And this is, oh yeah, this is the problem that might occur whenever we forget to pass the correct game object to our script. So if I go to my canvas, I can see that I have this as none, so there's no text. I have to drag it and stop it and drag it to pass that reference. Let's try that again. Okay, your score is 20. So basically it should be segments count -1 because we're not counting the head. Okay, and it stopped for some reason, so let's check our game over here. Is maybe for some reason it is happening. And I just might know why this is. So let's check. Yeah, we have game over. And that would be because we have our snake and we have box collider. And for any reason, it is still colliding with that. So maybe let's change it to 0.7 and let's check our snake head. Yeah, it doesn't look correct if you ask me. This is the snake. Change this to 0.72. Okay, let's change the scale. Okay, now the snake is not colliding with itself whenever it picks up the food. Let's check whether we can collide with ourselves. So we need to play for a while and gather the food. And as you can see, those new segments are popping actually here in our hierarchy view. Okay, I believe that's long enough. That's what she said. Okay, and let's try to bump into each other. And as you can see, I was able to do that, and that popped the game over. So now the game is no longer playing. But I think we could do better whenever we do the game over. So we're gonna add 2 buttons to our UI. So let's head to our canvas. And I'm gonna add 2 buttons. So let's go to UI legacy button. And that's gonna be a restart button. Yeah, and we're gonna add game over text. So to UI legacy, or if you have the previous version, it's just gonna be here in the UI text, game over, and let's design those quickly. The color, the font's gonna be our great new font. Color is gonna be red. So this is our text. The text is gonna state Oh no, this is the button. Text gonna say game over with lots of exclamation signs, and we're gonna center it, change the size, like make it really big, and maybe 20. Okay, let's change the font size. Game over. Okay, that looks good enough for me. And yeah, we can have that centered. Then we have the restart button. It can stay like that, but I have to place it at the bottom. So I'm gonna go to rect transform, click on that square, and then hold Alt and press the middle bottom row. The text for that, where is it? I'm not seeing that, but there's probably a way to change it. Yeah, okay, so the restart button has a text inside of it. So I'm going to just say restart game. And let's see how that all looks like. Okay, pretty good. One thing though, the game over text and restart button shouldn't be visible immediately. So basically we can go to our UI code, use this start lifecycle method, and we need to add the references that we need. So serialize field, private button, restart game button, and serialize field, private text game over text. And if you'd like to hide something, there are many ways to do this, of course, but one thing that is kind of cool and we can do for the restart game button, we can take the local scale, local scale, sorry, this is living on a transform, local scale, and set it to vector 3, 0, so it shrinks basically to nothing. And then game over text transform local scale, also set to vector 3, 0. And then we need to expose some kind of function to do that, to bring the scale back up, and I'm going to call this public void on game over, and I'm going to say restart game button. Basically, let me copy that, and we're going to search for vector 3 and not positive infinity, but something like we're looking for 1, 1, 1, 1. Okay, no problem. We'll create this one from the scratch. So new vector 3 and bring the scale back up to the full scale. Okay, cool. So probably on game over, we should reference our UI and call on game over. That's one thing. The last thing basically left for us to do is to reload the game whenever the restart button is clicked. So I'm gonna create public void on restart button click, and we'll trigger that function whenever the game is over and someone clicks on the restart button. And there are many ways to restart this game. We could just restart every parameter and bring it to the starting value, which would work. but there's actually a better way. We can use another package from Unity engine, and this is Unity engine scene management package. Basically, don't need that. And we can just call scene manager. Remember, every single screen in the Unity is a scene. You can call load scene 0 because we have only one scene that is living on the 0 index, right? So we can call scene manager load scene, and that's gonna restart our game. The last thing left for us to do is to actually make our button do something, meaning add the event listener to it. So here's the on-click handler that we have on our button game component. And we can click plus here. And then basically what you have to do is bring the object with the correct script. For our case, this is a canvas. And here I can look for the UI class and I will find on restart button click class. And now clicking on that button will trigger that function. So once again, you're dragging a game object, game object here that has the script in which a function that you would like to trigger lives. For us, this is a canvas because here is the UI script attached with the restart game function. So I'm gonna click here and drag it. Oh, sorry. I'm gonna go to our button and drag the canvas right here. Now that will allow me to search different classes here, and one of these will be the class that lives on the game object that you've dragged here. So UI, and then amongst all those find your function, and that should work. One thing we're missing, we have no references to restart button and game over text, and we can change that to be score text. Would this break the reference? No, actually not. So yeah, let's try this. Let's run this. So there's no score. Getting 1 and the next one and the next one and the next one and the next one. Okay, and let's try crashing into ourselves, and there's a game over information about the score and the restart game button, which I can click to start playing again, which is wonderful. So yeah, that's our snake game in Unity. I basically think I covered all the basics needed. And one thing though, what does it mean for our channel? Well, I'm definitely going to be creating more tutorials about Unity, since creating those games for the past few months has become my passion. But that also doesn't mean I'm gonna completely stop creating videos about React and web development. So I'll be just adding more. I already got another tutorial about Node.js and TypeScript planned, but also I would like to recreate few of these very nice retro games. Retro, that was the word that I was missing, because I think it's fun, and definitely it is something new for me. The complete something completely else than creating web apps. And I believe there's advantage to expanding your interests when it comes to programming. So let me know what you think about Unity, about game development, about me adding this type of tutorials to the channel. I hope you like it. If you enjoyed that, maybe like, comment, subscribe. It's always appreciated and help fighting against the YouTube algorithm. So that's all, and I'm going to see you in the next one. Goodbye.